The industry is currently stuck trying to build smarter and smarter filters for prompt injection, but we're completely ignoring the real prize that hackers are after. That prize? The real standing credentials that your AI agents carry right into untrusted contexts.
Let's get right to the core of the problem. The prize here isn't the hack itself. It's the live API key your agent is already holding. Think about it. If your AI assistant holds a real live master key to your company's data, literally one clever trick is all it takes for a complete stranger to win everything. It completely bypasses those expensive, sophisticated safety filters you just set up.
And the urgency here is absolutely real. OWASP has officially ranked indirect prompt injection as the #1 unresolved agentic security risk. Their warning is pretty stark. Absolutely no deployment model is immune when an agent's fundamental job is just to read untrusted data.
Section 1. Bypassing the safety net. How ordinary methods beat smarter filters.
We urgently need to look at the undeniable proof of this structural failure. Just look at the stark contrast between how absurd these delivery methods are versus the critical severity of the resulting data exfiltration. Take get loss, for example. It used an ordinary-looking public GitHub issue written to sound like a VP of sales. Because the agent had read access, it just grabbed a private repository's README and dumped it right into a public comment. Or look at ghost commit. A hacker essentially robbed a database using a simple PNG image. It hid instructions to encode secret bytes and sailed right past AI code reviewers because, well, they don't check images. These attacks succeed because agents are inherently designed to follow instructions.
Section 2. The true prize, master keys. The architecture of the confused deputy. These hacks aren't succeeding because the AI is fundamentally broken. They succeed because of what the agent has in its pockets when that malicious instruction lands. This perfectly illustrates a 38-year-old architectural flaw called the confused deputy problem. Imagine a deputy given a badge by a sheriff. The deputy isn't malicious, they're just following orders. But the badge executes its authority regardless of whether the instruction came from the sheriff or a criminal impersonating one. When an AI agent simply executes authority without verifying the source, it becomes the ultimate confused deputy.
Right now, we're treating this whole situation like a clever trick to pick a lock. We're investing heavily in input sanitization, complex filters, and continuous red teaming frameworks. But in reality, it's a bank robbery where the vault, the real live API key, the OAuth token, was just left wide open inside the agent's execution context. If the prize wasn't sitting right there for the taking, picking the lock wouldn't matter at all.
We're seeing this exact structural root cause in every major incident this year. Take Echo Leak, a zero-click critical CVE in Microsoft 365 Copilot, where an injected instruction used Copilot's real broad OAuth token. Or Little LM, where real AWS tokens were extracted in just 40 minutes via a supply chain backdoor. And then there's Jade Puffer, an autonomous ransomware agent that happily harvested root MySQL keys just sitting openly in the environment. In every single case, the shared flaw was a real long-lived credential with a massive blast radius left out in the open.
Independent analysis from GitGuardian summarizes this perfectly. They confirm that static, long-lived credentials are the attack surface that agents inherit and amplify, and that rotation programs only defer the root cause. Relying on rotation schedules is basically like trying to close the barn door after the horse is already bolted. It's entirely insufficient because it operates after the injection has already provided the instruction to that standing credential.
Section 3. Context-bound access. Securing the design layer. Here's the solution. If the credential an agent holds isn't real, the prompt injection is essentially worthless. This is why DevFortress secures the design layer by permanently removing real credentials from the agent's context. The architectural fix relies on a specific evolution of agentic zero trust. Step 1, remove standing master credentials from the context entirely. Step 2, issue context-bound scoped access, also known as alias indirection, which only resolves to real access at the execution boundary. And Step 3, automatically contain any behavioral anomalies.
So what does this mean in practice? By ensuring what an agent holds is only a limited artifact, we guarantee that even if a ghost commit or get lost attack fully succeeds in tricking the AI, the attacker finds absolutely nothing they can use outside a strictly authorized tiny scope. The real prize is completely gone.
Section 4. Sub-2-second containment. Machine speed defense for machine speed attacks.
Scoped access is really only the first half of the solution. The second half is a containment safety net, capable of stopping an autonomous agent the instant it deviates from its authorized baseline. Relying on a human-in-the-loop response is completely dead. During the Jade Puffer incident, That autonomous ransomware agent encountered a failed exploit step and self-corrected in just 31 seconds. Machine speed defense of under 2 seconds isn't just nice to have, it's mandatory.
DevFortress monitors from the very first request. The instant a scoped credential behaves anomalously, say trying to access an out-of-bounds database, automated closed-loop containment triggers. It isolates the threat and preserves the entire session for a forensic audit trail, all in under 2 seconds. The threat is stopped cold before a human even gets a notification.
To distill all this down, you have to stop letting your enterprise credentials be the automatic reward for every successful hack. By securing the design layer with zero-trust scoped credentials, you fundamentally eliminate the price. Alias indirection protects your outbound API keys, and a sub-2-second quarantine strips the blast radius from agentic workflows, completely removing that fatal human-in-the-loop latency.
Which brings us to the most critical takeaway. Review your own architecture today and ask yourself a very direct question. Are your AI agents still walking through untrusted contexts, holding the master keys to your enterprise? Is your agent's credential a prize worth winning? Because if the answer is yes, then every prompt injection is a critical threat waiting to happen. It's time to take the prize off the table.